welcome to the last panel of the day. We're going to be talking about interoperability in Solana. We've got a pretty stacked panel of different people from different venues. I would like to do the introductions a bit different today. So obviously say where you're working, what you're working on, but I'd love to for you guys to give an example of an event or experience that have shaped the way you think about interoperability. So I'll go first. I'm Mass. I do research at Maven 11. At one point, I had funds in a smart contract bridge that got exploited. And after that, I started caring a lot about smart contract security, but also thinking about the absence of that. So, having bridging or interoperability in the protocol layer itself. So that's an experience I had. If you want to go first.
Yeah, my name is Bo. I'm a co-founder at Polymer Labs, where we work on extending IBC to different chains. I wouldn't say there's like a specific event as much as I've been thinking a lot about like cost of maintenance of different systems. And to me, it seems like you want to, converge to constant cost of maintenance. If you have a system where the cost of maintenance grows over time, with these interoperability protocols, a lot of times that's the case. If you're interacting with a lot of different chains, you have different relay implementations, you have different clients, the attack surface of your protocol just grows over time. And you also have to keep up with upgrades, that sort of thing. So I'm like very bullish on IBCs, and also IBC becoming or converging to some constant maintenance cost over the long-term time horizon.
Like Neel?
Yeah, I'm Neel. I'm the founder of Eclipse, and we're building a Solana virtual machine layer 2 on Ethereum. And an experience that shaped how we think about interoperability was when Eclipse first started out, we were running a bunch of app-specific frameworks, or a bunch of app-specific chains for apps that were dogfooding our framework. So that's like Zebic, a bunch of games. We're running dozens of these. And part of that complexity was we had to actually run all this infrastructure, and that was painful. But another part was on the experience of developers that were using it. They had a bunch of interoperability issues. And that meant that they had to deploy bridges, and there was additional infrastructure surrounding that. There were additional trust assumptions that were often added. And just implementing bridging on the Solana VM is very different than EVM chains just because the pre-compiles or system programs that you have access to is a little bit different. Even the execution model is different, which we worked with Polymer pretty closely on scoping that out. But that certainly shaped my experience and my thoughts on interop.
Hey, I'm Nikhil. I'm a product lead at Wormhole, the Wormhole Foundation. Wormhole is one of the leading interop protocols, connects over 30 chains, and is fully open source, secured by 19 different validators who are all trusted, well-known actors in the ecosystem. Neel kind of stole part of what I was going to say in terms of something that shaped my view on interop. It's also related to developers and seeing the developer experience building on interop through various hackathons that we've thrown, or just working with developers on who are trying to build on Wormhole or trying to work cross-chain. And for me, it's kind of from the other side, though. It's seeing how there's a lot of complexity building cross-chain. There's different runtimes, different kinds of execution environments that developers need to work with. And then there's all the off-chain verification infrastructure. There's, with Wormhole, it's the Guardian set. Then there's off-chain relayers that deliver your message to where it needs to go. And all of that is complex for developers to think about, and it's important to abstract that away. And that's one of the things that we have been kind of thinking about a lot and working on really hard at Wormhole.
Yeah, that's a good point. Mert?
Yeah, hi guys. My name is Mert. I'm the co-founder and CEO of Helius. Helius is not Helium, by the way, which is the mobile network. People get that mixed up all the time. We're a developer platform on Solana. Yeah, it's an interesting question because I'm not traditionally, let's say, into interoperability, just haven't had the opportunity there. But actually, we worked closely with Neel on seeing how we can make kind of SVM nodes function. So we're a developer platform, we provide nodes and RPC infrastructure. And that kind of showed me that there's a lot of room here for improvement and kind of taking the SVM and that tech and bringing it over to other ecosystems and kind of just jamming on open source software.
I appreciate that. I think some of you mentioned, obviously, the on-chain and the off-chain aspects. Considering we are at a Solana Breakpoint conference, I would love to hear your views on not just Solana, but the SVM itself as sort of a settlement layer when you're bridging. So what needs to be changed? Do we need more curve support for different types of zero knowledge proofs or validity proofs? And what makes the SVM specifically useful as a settlement layer for bridging?
So we don't really think of the SVM as a settlement layer for bridging for our use case, given we consider Ethereum the settlement layer, and that's where we expect most assets to originate. And one way to even view layer 2s is just the existence of better bridging. We're building a trust minimized bridge, and that is the essential piece of infrastructure that we're adding. But as far as things that we'd want to change about the SVM, to support IBC, we had to add a couple more system programs. I'm trying to remember which curves those were. For some oracles, we had to add BLS, signature verification. So yeah, those are things that technically you don't even really need a precompile for them, because the on-chain cost of compute is slowly approaching the cost of adding a custom system program or something. So yeah, I think what's more complex about it is the fact that just because of the fact that the SVM is intended to handle parallelism with reading and writing locks, that execution model is a little bit different as well. So it's not as generic as using something like an EVM.
Mm-hmm. Yeah. So obviously, the SVM is generally used as an execution layer, and the reason, I think, we think it's a better execution layer is because it's multi-threaded. You can parallelize it. And it's also optimized with that in mind. But you mentioned settlement. That's actually an interesting thing that most people aren't aware of. There's actually a few zero-knowledge sovereign rollups thinking about using Solana as a DA layer and just posting data blobs there, because it can, processes a lot of data, obviously turbine with like continuous block propagation. And so I think, and then also obviously Maker wants to fork, or Rune wants to fork SVM for their own app chain. We'll see what happens there, but so you can kind of see the SVM and its tech stack maybe being more and more prevalent going forward in interoperability.
Yeah, it's definitely a very interesting moment right now. Right? First with Eclipse, and now a lot of others as well. I've heard rumors around the conference that the SVM itself is actually a lot easier to prove via CK compared to something like the EVM. Is that something you guys have experience with?
Yeah, part of that is because it's register-based, and a lot of the literature on generic ZK VMs is based on register-based stacks. And even when you make ZK EVMs, a lot of the time, they reduce that bytecode to a different bytecode entirely. That's what people might not realize about Arbitrum or Optimism or something. But when it's actually doing even fault proofs, it doesn't actually do it on the level of EVM bytecode. But instead, it's some other completely different interpreter, which is WebAssembly bytecode, or which is MIPS or something else. And part of the reason for that is that those are register-based VMs. So that's one reason. And then another reason why the Solana VM, or the bytecode, which is some variant of BPF or Berkeley Packet Filter bytecode, is easier. It's just because it's a more limited instruction set compared to the EVM, where there's a lot of instructions that are somewhat redundant. So you have to prove all of those separately.
Okay. And I will also consider we have Nikhil and Bo on the panel. I sort of alluded to it in the beginning that most bridging these days, apart from IBC and the custom ecosystem, happen on sort of an app level. So it's smart contracts, it's on the execution layer, and it's not like enshrined in protocol. I would love to get the two of you's views on, do we get to a point ever where not just IBC-enabled chain, but other chains are starting to enshrine a specific cross-chain bridging protocol, like a Wormhole, like a Polymer? Do you think that's a decision these chains should be making? So should Solana go and say, we're going to enshrine Wormhole into the protocol layer? Or do you think bridging itself should sort of stay on the app level layer, like it is now in most ecosystems?
I'm pretty opinionated on this. So I do feel like is a tremendous value in enshrining the messaging rules of an interoperability protocol, maybe not necessarily the verification mechanism itself. I feel like the verification mechanism should be pluggable and interchangeable, and different actors can build businesses there. Like, for example, IBC clients are an abstract way of representing some verification mechanism. It doesn't have to be a light client, doesn't have to verify consensus. It can verify whatever the implementation dictates. And in order to kind of like, I made a comment about like cost of maintenance of a system. If you can enshrine a protocol and standardize on messaging formats and how you interpret these formats, then that in and of itself like starts to bring down the cost of the system as a whole. And when you enshrine these protocols, you can even do like cool things like you can get rid of relayers. You can replace relayers with just a peer-to-peer layer, like overlay over different interop enshrinements on different chains, on sovereign chains. You can kind of have like interconnectivity across blockchains. Now blockchains are kind of like aware of what's going on cross-chain across this like wide-spanning network of chains, and I find that very interesting.
Nikhil?
Yeah, it's an interesting question. I disagree with Bo.
That's good.
I think that it's unclear, which standard will win in the long run. There are a lot of different standards for bridging out there. I think almost higher level about this, around the topic of enshrining in general, I think, it's up to the chain for sure, but I think it's almost like, in some sense, against like the ethos of crypto to enshrine protocols. You have your base foundational layer, which is the execution environment, the consensus layer of the chain. And then on top of that, you have different kinds of standards that can be built and different kinds of standards that can be adopted. And from there, the ethos of crypto is let the best one win. It's all about free markets, user choice, and there will be competing standards. And we should let those standards compete, and we should let the users and the applications that are built on top of them, and the builders and the projects ultimately make that decision on which kind of standard they want to coalesce upon.
Okay, so if we are not enshrining a bridging protocol into a chain, I suppose we're also sort of introducing new attack surfaces. So you're probably introducing a new cryptoeconomic security, like a state or a middle chain. So a Wormhole or an Axelar or a Polymer. So instead of us just trusting the cryptoeconomic security of two chains, we're essentially also introducing one more. So I would love to get all of you four's view on sort of cryptoeconomic security. Is that something that we need in these networks that are sort of handling maybe on relay level, but also if they're sort of coming to consensus on the messages being passed over? I think right now with layer 0, there's not really any cryptoeconomic security involved. It's just a relayer that somebody's running and an oracle. So would love to get your guys' view on that.
Yeah, I can start off as well, and then other folks can chime in. With Wormhole, the approach we've taken is we currently don't think that like cryptoeconomic security is sufficient for bridging. There are cryptoeconomic security constructions that have been deployed, but ultimately like cryptoeconomic security is based upon the value of a network, which can be much more easily manipulated than a sufficiently decentralized, well-known set of actors. And ultimately, I think that everything is kind of moving towards ZK. It's going to take a while to get there. That's, I think, the holy grail of security. But today, I think the best kinds of constructions are kind of validator constructions. And then also on your point, just to push back on your point a little bit about enshrining the messaging layers, I think that there's always going to be some kind of off-chain component, no matter what kind of bridging you have. Today, it's off-chain validator sets. Tomorrow, it's going to be ZK prover networks and things like that. So there's always going to be some kind of off-chain component that you're dealing with. It's just, again, up to the builders to decide which assumptions they're comfortable with.
Yeah, I agree with Nikhil's point that in general, you want to minimize the cases where you're using cryptoeconomic security to prevent an attack vector, just given that it's very difficult to bound what's the cost of an attack or in general for interop, there's also like a larger blast radius. If a bridged asset suddenly is hacked, then that can have other impacts that you have to include the cost for. But ultimately, like ZK doesn't solve that, because even if you have a ZK proof of the execution of some other chain, that chain is still bound by cryptoeconomic security guarantees. If it's a proof of stake chain or something, it's the quorum that's determining like what's the canonical chain, for example. So all you've proven is the correctness of execution, but changing the reorg resistance is still based on cryptoeconomic security. So that's one thought. And then on enshrinement, I don't know if it's necessarily against crypto ethos to enshrine things, just given that, I mean, for layer 2 networks on Ethereum, obviously there's an enshrined bridge. That's an essential part of the network. And you do have to pick one for the chain, because if you're doing gas in Ethereum, for example, or in Ether, then you need to pick what representation of that Ether is going to be deemed to be canonical. What's going to be the gas for the chain? Is it going to be Wormhole ETH, or is it going to be the ETH that comes through the canonical bridge, or something else? So you do have to pick at some point. I think there's immense value in doing that, because it solves this fungibility issue with assets, where when you have like 5 different bridge standards, then all those assets are no longer fungible in the same way that you'd want them to be in a DEX or something like that.
Yeah. I guess you have to be careful we don't start talking about alignment. So are you Ethereum aligned, Solana aligned? It could be troublesome. Do you have opinions on cryptoeconomic security in particular?
Yeah, I guess just to add to what everyone has been talking about, maybe to add on the ZK point, I'm not like, it depends. ZK using ZKPs depends on what you're verifying. You can verify the execution of a chain. I think in some cases it's not always necessary. So like between Cosmos chains, you could have ZK proofs of consensus, or you could just have regular consensus proofs. You're verifying the same thing, whether it's using math to verify it or just in plain code. And even if you want to verify the execution of a chain, you don't necessarily need to run the execution yourself. You can have an optimistic system where perhaps maybe like on Solana, you have some sort of like embedded MIPS or a RISC-V based machine, and you can have some sort of challenge game where you can challenge a state transition, and you can get still like a 1 of n assumption in terms of trust with much less compute, while not having to pay like the off-chain prover cost and all the costs associated with ZK and other complexities.
But I guess if you don't have a chain of support like clients, I know, for example, the Guardians on Wormhole in particular have to run a full node, I think, on every single chain they support. And I'm assuming that's a pretty hard like hardware cost, maybe some DevOps costs related as well with salaries. So is ZK a way we can sort of start to lower the cost of doing some of this bridging and the verification of it? And if that is the case, how far are we out from that kind of future where we are using ZKP, zero knowledge proofs, to sort of do a lot of this verification? Because it seems quite expensive now to do a lot of the proving, right?
Yeah, definitely. I mean, you're right. Today, the Wormhole Guardians run full nodes for maximum security of every chain that Wormhole supports. And the Guardians are like big validator companies, so they're used to it, but it is a cost. And using light clients can help reduce that cost. How close we are to that, how close we are to a world of Solana light clients, I'm not the best person to ask on the latest research there, but maybe Mert can tell us. But it's not. I haven't heard a ton of progress aside from maybe things like Tiny Dancer.
Yeah, that's pretty much it. I would say, so Tiny Dancer has been making some progress. They're actually giving a talk if you guys are interested. But other than that, I think, and I just saw Matt leave, but there needs to be some more core work towards light clients on Solana, and that's really the biggest missing piece. I was actually talking to, I think, some people interested in this, but Cosmos and BD and grants, how that works. And so I think maybe we need to set up the right incentives first.
Now that I have you around, Mert, as well, I would love to ask you, considering you have a completely different background here, you have a more sort of dev-focused background doing dev tooling at Helius. What are some of the pain points that you've seen? So when people are trying to build something related to interoperability, whether that's a cross-domain application or whether it might be, what are some of the problems that they run into? Is it primarily around like different types of wrapped tokens, or is there something else that's difficult? And do they care about security? So we're talking about security here, but do most of them care about it?
Yeah, I think it's an interesting question. Generally, on our end, the teams that obviously are doing interoperability are on multiple chains, and so they would ideally prefer providers who do expand multi-chain as well. But in terms of, and then like Solana, for example, the most common thing is like Solana's programming model is just very different than EVM, right? Like Solana doesn't even have interfaces. There's no ERC20 or ERC721. Instead, we kind of have like Metaplex and SPL, which is totally different. everything is decoupled, right? You have accounts and transactions, which is everything being in the same kind of construct. And so it's generally just, to be able to answer those questions, we need to understand kind of all the different ecosystems. But they're generally kind of just education problems, I would say. And, like Solana, for example, archival is a total different beast. It has like 400 terabytes of data going back to the history, which is, not small. And so just, teaching people how different Solana is usually the biggest developer education, really. But Neel would probably know a bit better based on working with developers who might deploy on SVM.
Yeah, agreed on the education point. I feel like people don't know how to think about security. At least dApp developers often don't know the right way to think about it. And we'll often get questions from people such as, is this bridge secure? But really the right way of framing that question or reframing it is, what do you mean by security? Are you concerned about liveness, or are you concerned about, most likely they just don't want the bridged assets to be hacked or something. And even then the answer is a little bit more complex than an apples to apples comparison, because Wormhole has 19 guardians, but there's sufficient, they could be very decentralized and in different regions, as opposed to another quorum which might be a larger number of guardians, but maybe they're all here in the US in the same state or something like that. So it's not so simple to assess which is more secure in an apples to apples way, and it requires more thinking on the part of the dApp developer.
And I guess it also depends on the implementation itself, right? So if you have Nomad wasn't really on their security guarantees itself, but it was more of I think every entry smart contract. So there's also a lot of smart contract risk, I guess, associated with that as well.
Yeah, agreed. Yeah, I mean, what's good about standardizing at least a serialization format like IBC is that you're preventing an entire class of errors that could possibly occur. Of course, you could get Wormhole working with IBC, for example. You just you can make it use multi-sig instead of using a light client for verification. And
yeah,
you could
I think they actually have. Looking at the GitHub of Wormhole, I think there was some work on some IBC stuff, right?
Yeah,
I think there's a Wormhole
we launched a chain that allows for fungible bringing assets that are fungible into the Cosmos ecosystem. But yeah, totally. What Neel was saying, Bo and I have talked about that a lot before, actually.
And now that we're sort of getting into IBC, I would love to get your views on one of the other sort of off-chain actors here, which is the relayer. Not the relay in PBS on Ethereum, but sort of the relayer in IBC. They're, I think, right now running, obviously you have hardware costs, just like a Guardian, for example, but they're not really getting any sort of fees from handling and relaying these messages to different chains. So I'd love to get your view on, do you think relayers should be incentivized? Should they be allowed to, should we have priority gas auctions on what message goes through quickly so they can extract some MEV? Or do we go back to it should be minimally extractable? So I'd love to get your view on sort of relayers as a whole.
Yeah, I can start off. I mean, we think that relayers should be incentivized. We think that's a part of the stack that it makes a lot of sense to extract value from, because the relayer is providing a service of getting your message to where it needs to go. We've been working on features. We have this feature called automatic relaying that is trying to create a network of incentivized relayers where you pay for gas up front and then the relayer will deliver your message on the destination chain. It's like an initial system, something that we released to support some pain points of projects that integrated on top of us, but there are lots of other interesting schemes that you can come up with for incentivizing and paying relayers.
And is that like a static fee, or is it a fee that is sort of has priority fees involved, so you could essentially...
Today it's just static fees that get paid up front on the source chain, and then the relayer is effectively bearing the risk of the price risk by the time they deliver on the destination chain and pay that gas cost. But there are like what you're mentioning, there are other more complex mechanisms that you can come up with.
Okay. And I think you've actually talked a bit about incentivization before on relayer level.
Yeah. I mean, there's incentivization scheme on top of IBC already. It doesn't support advanced functionality such as gas refunds on a destination chain, but it is kind of like a basic framework for enabling incentivization. But I think for myself, I'm way more excited about the idea of just completely getting rid of relayers long term. It's just like additional infrastructure that you have to run. They can go down. They may not be watching different chains. To me, it just makes much more sense, like long term, to kind of have some like interconnected, broader system, like an interconnected overlay. And I know that I think Informal Systems did a hackathon recently on IBC Sync, and that's kind of like basically the first like exploration of this idea that we've seen.
Okay, that's good to hear. So hopefully we get to a world with no relayers.
Yeah.
Do you expect that to happen, or is that a pipe dream?
I expect that to happen, actually. I know Nikhil doesn't like the enshrined interop thing, but I do feel like when you enshrine things and you standardize on things and you have like a consistent, it's like P2P like overlay relay network, then you don't have to. For now, like a lot of people don't realize that these relay implementations are custom per chain. Like if I have an interop system that's like smart contract based and I'm deploying these different smart contracts to different VMs, well, guess what? Like the transaction format's different. RPC endpoints are different. The count system is completely different. And it just gets quite like complex and unwieldy to maintain all these different implementations.
So if we don't get sort of, let's say we're in a world with no standardization and there's a lot of different sort of implementations, I'm assuming there'll be some sort of UX hurdles in this type of world, and we have those already. Do you guys, of course, we're seeing on Ethereum sort of with account abstraction and things like that we might get bundlers, solvers, intents. We're throwing out all the words here. So do you guys expect a world where we just have like a single aggregator that has a bunch of solvers that are running on different chains, and then they'll handle all the messaging for them? Or how do you sort of see, I think, intents in particular and sort of solvers and bundlers to sort of fit in here?
From our perspective, it's really hard to see how intents will play out for many applications. I think for simple stuff like swaps, that's easy to make sense of. But when you consider the wide variety of apps that crypto will support, it's a little bit harder to see where that's going to land. So I'm not sure if it's going to be so fungible that you just send it to a single aggregator.
Yeah, at least it's, I guess, token in, token out. As you said, I think it's probably easier, and then that kind of makes sense. Beyond that, I would love to sort of hear about what UX pain points that you guys would love to fix now. So I think you're all working on UX to some extent. So what UX problems still exist in bridging in particular? And what would you change? So I think maybe one is wrapped tokens. Would you love to see no wrapped tokens? So can we come on maybe a standardization just on the token level, that we just have one sort of token model that we use when you're bridging stuff?
Yeah, definitely. We can definitely find standardization at the token level. I think there's some wrapped tokens you're never going to be able to remove, like transferring native Ethereum to Solana will always need to be wrapped because you can't, burn it on the source chain. But beyond that, protocol level or application tokens, CCTP is a great example. Other stable coins, other projects that are launching their own token. I think it makes a lot of sense to have token standardization. And wrapped assets can cause like a liquidity fragmentation and other difficulties.
I like wrapped assets though, because if one bridge gets exploited, it doesn't just completely destroy the asset. Then it's just that one. I mean, we saw that with UST and the Terra ecosystem. That would have been catastrophic if just a bunch of other stables came down with it.
Yeah, so you kind of, even though it's fragmented on a liquidity level, it's also, I guess, fragmented
from a security
level as well, which I guess is pretty important too.
I think like giving projects, maybe it's not immediately sort of, the speed at which a hack can happen is difficult to cope with, but like giving projects, flexibility in being able to add different messaging providers to be able to mint their token on different chains is something that can help a lot with that. And then adding things like Wormhole has this. There are other standards out there that are trying to develop stuff around this, but like things like rate limiting, things like chain accounting to make sure that that you can't an existential threat on one chain can't kind of boil over onto another chain. Those are also really important security features that need to be added into token bridging.
I think particularly rate limiting, like if we had rate limiting with Nomad, for example, the hack wouldn't have been as catastrophic. But I guess it's also limited in the sense if I'm like a market maker on DYDX or something, and I'm moving 100 million in USDC. If I'm rate limited at 10 million, that's a bit of an issue, right?
Yeah.
So if we have rate
yeah,
limiting,
rate limiting can be kind of a double-edged sword in that sense, and maybe there's some more exploration to do on how to like give projects flexibility in how like they have their rate limiting done on per bridge basis, or like Wormhole has a governor feature giving projects flexibility on like different projects have different kinds of rate limits, and it's not like ecosystem wide. But yeah, I think rate limiting is super important. Also, accounting is super important. Making sure that you can't extract more value out of a chain than what's been bridged into a chain. That's really important.
Challenge periods can also help, even though that damages UX. It's the hidden benefit of optimistic rollup. You have a little bit of time to respond to an exploit.
You guys are kind of doing that with the CK for proofs, right?
Yeah, exactly. Yeah, so it shortens. Actually, so it gets a little more complex than what the challenge period ends up being, because you can shorten it under certain conditions too. So which also means you have less time to respond to an exploit.
But I guess the end game would that be Eclipse as a CK rollup down the line?
So right now, the cost of ZK proving every transaction in the chain would be too expensive, because we want to mimic the Solana property of being very cheap. That's part of why we're using Celestia and why we've architectured in the way that we did, because an optimistic rollup just doesn't have to prove everything. Then the advantage of the ZK rollup is that you can just post state diffs, so you don't have to actually make every transaction available, which is kind of nice. So
and I guess you can post like more transactions into a single proof as well.
Mm-hmm.
But if the cost is so high,
scale.
So I guess for now we don't have that many users. But if we are in a world with a lot of users, it would make, I guess, more sense.
It could be more economical. Right now, the base cost for proving a transaction for us is about 10 cents. If you're assuming like an AWS instance that's running for however many minutes. But yeah, we'd have to get that down by like 100 times or something. So it's something pretty substantial.
All right, so we're not quite there yet. But thank you so much, guys, for joining me on the panel here. And it was great to hear. And thanks for the invite for Polymer and to Solana Foundation for hosting.